Why are real numbers fundamental for advanced physics? Imagine trying to measure the distance between planets or the speed of a falling object without a clear way to describe continuous change. It would be nearly impossible. That's where real numbers come into play. They are the backbone of how we understand and describe the physical world in advanced physics. Real numbers include all the numbers you see on the number line, positive numbers, negative numbers, zero, fractions, and even irrational numbers like pi or the square root of 2. This vast collection allows us to pinpoint any measurement along a smooth, continuous scale. In physics, many properties like length, time, temperature, and speed change smoothly and without sudden jumps. To describe these changes accurately, we need a mathematical system that can handle any value along a continuous spectrum. Real numbers provide that system. They are complete, meaning every sequence of numbers that gets closer and closer to a certain value will actually reach that value within the system. This property is essential because it allows physicists to work with limits and derivatives, which are the foundation of calculus. Calculus helps us understand how things change over time or space, which is vital in describing motion, energy, and forces. When physicists analyze the movement of particles, they use real numbers to specify positions and velocities. For example, the position of a car on a highway can be any real number, not just whole numbers. Time is also treated as a real number because it flows continuously, allowing us to track how systems evolve moment by moment. Even in fields like thermodynamics or electromagnetism, real numbers help describe temperature gradients or electric fields with precision. Although quantum physics sometimes uses complex numbers, which combine real and imaginary parts, the results we observe, such as the likelihood of finding a particle in a certain place, are always expressed as real numbers. This shows that real numbers are at the core of translating mathematical models into real-world measurements. Without them, it would be impossible to describe the continuous nature of physical phenomena accurately. In short, real numbers are fundamental in advanced physics because they match the continuous, smooth nature of the universe. Their properties allow scientists to create models, solve equations, and make predictions with clarity. They help turn abstract ideas into precise descriptions of how the universe works, making complex topics easier to understand and work with.